facility should implement access policy and financial policy, service contracts, regular upgrading, and etc. And single groups should probably possess some niche instruments, like in electrophysiology in instruments, and they have especially Faraday cages for live cell. So let me yes. So electrophysiology, so inverted microscope, and it's a basic confocal inside the Faraday cage. And for live mice imaging, it's also belong to a single group. And it should be upright and 2-photon microscope in this case. Or recently we made, we won a grant for a special microscope for infectious room, for where people operate with very dangerous viruses. It's a C3 laboratory, just to compare. COVID is C2, and that's more dangerous viruses. So it should be inverted because it's for the cell culture. It should be epifluorescent, robust, mostly mechanical. It should not break. I will talk especially about mechanic versus motorized. And remote operations are very important. So then in a teaching and tissue culture. So so another niche instrument should be a microscope like this, but it could be also belong to the core facility. So a microscope like an IncuSite, and that belongs into the incubator. That is special for long-term experiments with live cells. That's just the best. So it has a footprint for multiple dishes or flasks. So it could operate multi-position and fluorescent and transmission channel. So in a tissue culture room, so how I did it 2009, how I picked up the microscope for tissue culture rooms. So the point was to prevent people from coming to my imaging facility and turning on the confocal microscope to check efficiency of transfections. What we had before in the core facility, it was just phase contrast microscopes, no fluorescence. So, and we did a made a compromise, a microscope that can make phase contrast and record phase contrast imaging, and makes a simple fluorescence with 1 or 2 channel. In this case, it's 2. It's green and red fluorescence. But as you see, the camera is not good enough here. I don't know if you see my mouse. So the camera is not good enough for imaging of fluorescence. It's only good for transmission light. But the point was, if you try to make a camera good enough for fluorescent imaging, that's already core facility microscope. That camera alone would be more expensive than the whole simple microscope like you see here on the picture. Nowadays, in amendments, so in comparison to with 2009, I would pick a camera with no mirror, so like Sony instead of Olympus or Canon, and so camera could be connected to a smartphone. I will show you later, and a white LED for transmission light and for fluorescence, so it will be just more sustainable. But basically, the microscope is good enough. So, and that is what I mean, the camera. So that is just an example, the camera for teaching and tissue culture and for simple purposes like that. Very user-friendly, and this is just an example. I don't advertise this particular brand because a friend of mine just constructed from the Raspberry Pi something similar, and you can shop whatever you want. But the point is that the camera is connected to a mobile device by Bluetooth or Wi-Fi, whatever, and you can tether the image directly to your screen, and it helps for imaging, it helps for focusing, it helps for teaching very much. So another approach for simple inventions for core facility is a microscope like that. A student of mine helped me to make it. We just put a mirror camera again. Nowadays I would use a mirrorless one, and it's a couple of adapters and a gallows to exchange to modify magnification, and a simple finite lens at the end, 4x to 10x or maybe up to 40x, very cheap, and it's a surprisingly good quality. You can see the picture, it's a live picture on the screen, and more scientific application like that. You can use it instead of a stereo microscope, and it makes a much better quality of images. And also, what the lockdown taught us in 2020, 2021 is that all operations, and especially trainings and assisted sessions, could be done remotely. And even after lockdown, I would keep this way, because I like this, because the team viewer allows, so we can use Zoom or Teams for communication and team viewer for remote operation. And the point is, of course, to get licensed version of the software. Otherwise, after a couple of users, you will be kicked out of the session. And we bought this just a multi-user license, but nowadays also educational licenses are available. After our license expires, we go to a special promotion. And first of all, I can on this session, I can train more than one student, multiple students. Then in some cases, I can make a first session with myself or a team member operating the microscope, and then just people swap. Others watching, and then they swap and get hands-on experience one by one, and all others are watching. And a full service option is also available for clinical and industrial clientele. So I can sit in the microscope, or a team member can sit in the microscope, and a person from a clinic or from industry sees what we are capturing in light or electron microscopy, and says, okay, we need zoom in, zoom out, move left or another left. And then, even the person can take over the control and say, oh, this is the structure I wanted to image. And that's very useful. We'll keep that way after all restriction will fall down. Okay, and another, just without any connection, what I'm using for teaching and training, actually it's more teaching than training. It's a very nice app. I wanted to advertise for that. It's Andrew Barlow did it. It's called Resolution. It's available for Android and for iPhone. I recommend to everybody to download and use it on your mobile phone. So it's a link here. And another point, smart dishes. So this was the question on my module for this PhD students. I thought it's very simple question. That choose the slices and dishes out of 4 options available for or suitable for live cell imaging. So just EBD dishes, you see here with a full description. So shows all the parameters of the dishes, which of them are suitable and which are not suitable, and why. And that, to my surprise, almost everybody failed. And I think I cannot emphasize more and more that for live cells, for inverted microscopy, we need a cover slip grade bottom for the slides and dishes, and this one is not suitable for it because of the thickness of the slide, 1 millimeter, and it's written here, it's 1 millimeter, it's not suitable. the best what you can do is probably 10x, and even then the quality would be not the best. So then the next point I wanted to emphasize today is upright versus inverted microscopes, because upright and inverted, they both belong to the core facility, and people tend to buy inverted microscopes only because they look universal, but it doesn't mean they're better. So because they have plenty of disadvantages. And you see, I put here the picture of stalactites and stalagmites. Like, you know, in upright microscope, the objectives they grow down, so like stalactites, and in inverted they grow up like stalagmites. So they grow very slowly, but they do. So, and upright microscope, they save a lot of time, because you can operate twice as many slides in a unit of time in comparison with inverted microscope. You don't need to take off the sample to apply the oil, for example, so you don't lose the location. And it has no chamber usually here, because it's not for live cells, and live cell people don't go to eat. And it also very important problem I have with inverted microscope nowadays. I don't know how others do, but we recently bought an Olympus confocal microscope, and since 2 years we cannot, the Olympus cannot resolve the issue with the focal drift, and partially it's because in an inverted microscope it's a very heavy nose piece that's sitting on this focusing mechanism, which is completely different. In an upright microscope is light, and the stage is much lighter, and they never have this issue. And also it's much better for transmission light. So just 3 examples of upright microscope in my facility. That's a special microscope for transmission light only, and it's a dedicated microscope only for that. No fluorescence at all. And the only part, well, this is the paper we published 2 years ago with that. It's just a single shot with transmission light microscopy. It's a mouse gut, it's a mouse colon with a normal mouse and in mutant. And you see mutant lacks of layer of the mucus, and bacteria go everywhere inside the crypts. So that was the reason of inflammation. So that has been published and even landed on the title of a good journal. And the only part of this microscope I will change right now is the camera. Again, it's mirrorless nowadays. It's better. So another microscope is a working horse in the facility, is an upright microscope for epifluorescence. And again, the only part what I exchanged from the original setup from 2003, I inherited this microscope, is the camera, because it needed a smaller pixel size. It matches better the Nyquist ratio for all the objectives. Again, back to the resolution up would help you immediately to pick up the correct camera for the correct objective. And the final one, that's a microscope we acquired last year, actually efficiently only this year, because it was very long time required for installation. That was LSM 800 ARI. Well, we had only budget for X-demo machine and for upright one, but I'm very happy with that. And it makes fantastic images from slides in very minimalistic setup. Okay, my point is, so we shouldn't avoid over-engineering of the machinery. So so we should take the microscope for the purpose, and separate them for fixed slides and for live cell imaging. 2 different sets of the microscope should there. And for analysis, we separate it from the acquisition. That's the first point. And second point, so we implement the server, connecting all the acquisition software, and it connected also to the working station. And third point is we use only a platform independent software like Imaris and NotSize or Leica, and possibly also Fiji and Micromanager to operate the microscopes, and also Elastic for more advanced issues. Okay, and a little bit about the setup of my facility. So it's light and electron microscopy. They have both advantages and disadvantages, and we know that. And they have also limitations. And limitation of light microscopy is low resolution, which is very sad because no cell organelles can be visualized without labeling. It's a poor structural recognition and poor 3D. And limitation of electron microscopy is limited to a tiny volume, and it's poor molecular recognition, great structural but poor molecular recognition, and also poor 3D. And we have two solutions for how to close the gaps between them. Is super resolution and correlative microscopy. And I'm very happy with launched last year a consortium with another university, and they took super resolution part and we correlative microscopy part. It's the nature of the facility because we have light and electron, which makes us unique in Ireland. So, so some principles of functioning of the core facility. So 1 hour thinking saves weeks of frustration in lab, but many people forget to make brainstorming before starting the experiment. So in a brainstorming, we reveal hypotheses, check our options, and set up the working plan. Then, of course, we take responsibility and we repeat this process. It's iterative. We repeat after the results, correcting plans, correcting hypotheses. And so it's the approach from simple to more complex, and from in vitro to in situ to live cells and try to in vivo. But it's just a general principle in biology, biological research. Okay, so aims of the core facility. First and foremost is to provide scientists with access to working microscopes, organize training and sessions, assisted sessions, concentrate the field on field of excellence and not compete with others, but collaborate. That is a role of a service provider. Then we participate in planning and conduction of experiments, as well as in discussion and publication. And as work as a meeting point for scientists from different backgrounds. It could be somebody from microbiology, somebody from virology, but they have a same cellular approach, a same microscopy approach, and they never met outside of our facility. And we combine them and they benefit from each other. So a new project begins with a brainstorming, as I mentioned before, and that is a role of the expert in imaging and partner of science. And you can read my mission statement. We translate our scientific problems into a working plan. Okay, so manage the staff, of course, deal with service engineers and application specialists. That's a role of the management, of manager. Develop new tools and strategies, and that's engineering, teaching, and generate income. It's a business. So it's a multiple role of the core facility. So, sorry, my German. So, you know what's Wollmilchsau? So, kaufen Sie keine Wollmilchsau. It means don't try to buy a mixture of a pig, cow, sheep, and chicken, because it will probably lay eggs, but very small eggs and very few. It will give you some wool, but very few, not very good. And the milk will be not good as well, and very low amount. So, and the whole thing will be very expensive and good for nothing. So instead, try to separate the tools and trim them for particular purposes. So about motorization, I would say the over motorization increases the prices, makes system complex and less precise, and motors break sooner or later. So why I would recommend not to motorize a nose piece for objectives? So because you never alive will change objective during the experiment, during the one time-lapse acquisition. It's just not possible, and most researchers do have hands to change it. And if you don't, it will also difficult to change it with a mouse. Filter turret, yes, because we needed to acquire with the different fluorescent channels, we need change the filters in the turret. Light path switch, no, please, no, because that breaks first in a microscope. And if it broke in a half position, you screwed, and the engineer visit will cost you a lot. In a lockdown, it will cost you a lot of time as well. Stage could be discussed. It depends on your of your purposes. Condenser, please no. Condenser you never change during the experiment, as well as a diaphragm, and filter wheel, of course, yes. But that probably it's a lot of beta experience of mine in this table. We can discuss. So please ask me questions if you wish. So and now I wanted to tell you what is poorly designed in the current microscopes overall. So I would say first is the chambers. The climatized chambers are just poorly designed. That's our new Olympus microscope on the left. And you see the chamber only covers the upper part of the microscope, but not the microscope body. And the microscope, well, the system loses heat through the oil. And it's very poorly designed, and we have thermal drift and heat loss of the cells. I prefer thermal chambers like that. Unfortunately, I have only one of them, and it's a great chamber. It includes the whole body. And the next one is the heater for the chamber, because even here you see it's just a hot air, and what I called it's a aufgemotzter hairdryer, or it's a heated, well, tuned hairdryer. And when it broke, so when I have seen the quotation for fixing it, several thousand €. Instead, I bought a heating element for €100 and a controlling element for another 100, and we connected it for another €25. With a probe, and this heating element serves me already for more than 10 years, and it's more accurate and makes no vibration. Another part is exactly same point. So you see this chamber, this case is from Zeiss, and you see we had a footprint only for round dishes, and I need it for slides and for multi-well dishes, and they quoted me for multi-well dishes, separate units for 25 well dishes, for 96 well dishes, and each of them €3,500 plus VAT. And that was, I thought, okay, you can keep your units by your own. And our workshop constructed me just footprint here and a little bit elevation extent, and the cover with it's a plexiglass on magnets, and that's a nozzle for CO2 input, and here's even output. You can measure CO2 content in this situation, and that's it works at least exactly as good, and the construction costs are negligible. Okay, fine, and I think I'm at the end of my presentation.